Hello everyone, welcome to another video. This video is going to be about solving right triangles. So we're going to be given some problems and we're going to have to find some missing sides, and to do that we're going to be using our primary trigonometric ratios. Okay, so we've seen sine was opposite over hypotenuse, cos, that was adjacent over hypotenuse, and then tan, that was opposite over adjacent. And what we used to remember this was SOH CAH TOA. Okay, so SO is for the sine, opposite hypotenuse, CA is for the cos, adjacent and hypotenuse, and then the TOA is for the tan, opposite over adjacent. Okay, so it's just a way to remember those, makes it a little bit easier. Pythagorean Theorem we got here next. We're also going to be using this for some different problems, and we should have seen this before quite a bit. And that theorem is a squared plus b squared equals c squared, where the c squared, that was the hypotenuse. Okay, so the c always has to be the hypotenuse of the triangle. So if I drew just a quick triangle here, there's my 90. Okay, the C is on the hypotenuse, the longest side, across from the 90. And then the A or the B, it can either be one or the other. It doesn't matter. I could have these flipped and it would still be the same. They just got to be on either side, but the hypotenuse has to go on the long side. Okay, so we're going to be using those two things, and then also this next thing is going to be really important when we're given some information. So it says the angle of elevation and angle of depression. So angle of elevation, we have that one here first. Okay, that is from your line of sight. Okay, you're normally looking flat. Okay, if you start to look upwards, that is your angle of elevation. So this angle right here, that is the angle of elevation. And if I wanted to give this angle a name, okay, we have to use the letters B, A, and C. So this would be angle B to A to C. Or another name I could call it, rather than going this way around from BA to C, I could go this way and go CAB. So it could also be angle CAB. And those two angles mean the exact same thing. Okay, so that's what this angle in here could be called. The angle of depression, now this one is when your line of sight is flat like this, but instead of looking up like we did with the angle of elevation, angle of depression, you look down. Okay, so depression, think down. So the angle of depression is this angle right here. Okay, so that right there is the angle of depression. And if I wanted to give this angle a name, I can use the letters Q, P, and R. So I could either call it angle Q to P to R. So angle Q to P to R. Okay, or this could also be from R to P to Q. So it's just going the other way. So angle R to P to Q. Okay, so both of those angles are the exact same thing. They mean just this angle right in here. Okay, so down below here we got just another diagram of our angle of depression and our angle of elevation. So again, angle of elevation is when you look upwards. So let's say you were standing right here and you looked upwards. That's your angle of elevation right there. And then we could say if you were right here and you were looking downwards, this would be your angle of depression. Okay, so looking down, angle of depression, looking up, angle of elevation. So on to our first example here. First one says solve the following triangle, round each side to one decimal place and angles to the nearest degree. Now the word solve, whenever you guys get the word solve, that means to find all missing sides and angles. Okay, so we need to find all the missing sides and all the missing angles, and we got to do our sides to 1 decimal place and our angles to the nearest degree. So first thing we can find, and first thing you guys always want to try to find, is always try to find angles, because angles are going to be the easiest. So I'm going to try to find this angle right here first, and that angle I can call angle B, or another name for it is I could call it angle from A to B to C. So it'd be angle A, B, C. Or another name, I could go from C to B to A. That would also give me that angle. So it can also be C to B to A. So all those mean the same thing. Angle B is kind of the easiest name for it though. So if I wanted to find that angle, we have to know a property about triangles. We have to know how many degrees are inside of a triangle. I can see this is 90, so we already have more than 90. Then we got 49. But all together in one triangle, there is 180 degrees in a triangle. So picture I had, say, $180. Okay, you were going shopping and you had $180, and you were going to spend it. So you could spend $90 in this corner, so you just lost $90. Then you could go to this corner or this store, you spent $49, and then the last store you could spend the rest of what you had at that last store. So it's like you had $180, but then you lost 90, and then you lost 49. So it's just like money, it's the same kind of thing. So 180 subtract 90 degrees, subtract 49 degrees, that gives me 41 degrees. Okay, so I know what angle B is. Next, then we can try to find a side. So I'm going to try to find this side right here. Okay, and if this is angle A, across from angle A is side A. Okay, so this is side A. And if I was describing it like I was standing at this corner and I was at the opposite end of the triangle, I would call this opposite. This really long side across from the 90 is the hypotenuse, and then this close side here is the adjacent. Okay, so I want to try to find this opposite side here. So I have to use an O, and I'm just going to write up my acronyms here. We have SOH, CAH, and TOA. Okay, and I said this had an O, so I'm going to have to use one with an O, so that's either the TOA or the SOH. It's got to be one of those two. And then looking at my hypotenuse, there's no number there, so I can't use one with an H. So I can't use this one, and I can't use this one. The only one that doesn't have an H is this one. So I'm going to use the TOA. Okay, and also I could say for another reason how I know I'm going to use that. I have A and I have O, so I'm going to use TOA. A and O. So tan theta is equal to opposite over adjacent. And then I can plug everything in. So tan of theta, the angle was 49. And then opposite was the letter A. And then adjacent was 15.1. Okay, and then this isn't one where we're finding an angle, so I can do that cross multiply divide and to get my answer. So A is going to be equal to cross multiply those two, so 15.1 times tan of 49, and then all of that divided by the one across from the letter, so divide by 1, which won't change anything. Okay, so when I put that into my calculator, that's going to give me about 17.3705, and then some other decimals. Okay, and then it said we had to round all of our sides to 1 decimal place. So I'm going to round to 1 decimal place. That's that one right there. In this case, the 7 is going to round up to 3. So I get 17.4. And then our units, I can see right here, are feet. So this is feet. So that one is done. Lastly, we just have to find this hypotenuse side here. So to do that, we're going to have to use h for hypotenuse, and then I'm going to use adjacent. So an a and an h, that is the CAH. So I'm going to use cosine. Now the reason I don't want to use this side is because I found this side. If I got that and this is wrong, and then I try to use it over here, I try to use the opposite, maybe I pick this one instead. Okay, if I made a mistake here, it's then going to mess up this. So try to only use original pieces of information, okay, like the adjacent. So filling in my cosine, it was cosine of the angle, 49 degrees. Adjacent was 15.1. And then the hypotenuse, that is across from C, so we can call that little c. Okay, so I'll put that in, little c. And then I can do my cross multiply and divide, just put that over 1. So c is going to equal, cross multiply those two, 1 times 15.1, and then divide by the cos 49 degrees. Okay, and then we'll put that into our calculator. This one I'll actually show demonstrating it. So turn it on, and then we're going to go 1 times 15.1, and then divide by cos of 49, and then make sure you close your bracket around the 49. Okay, and then before I click enter, I know my calculator currently it's in the wrong mode. So I got to click mode, and I got to go down, move this over to degree. So go down, over, click enter, and then it's lit it up. So now it's in degree mode. Okay, so if I would go back to my main menu and now click enter, now it's going to give me the right answer. So I get 23.0162. Okay, and then our sides we need to round to 1 decimal, so just that one. The 1 is not going to round up to 0 though, so we just get 23.0, and then our units again were feet. Okay, so we're all finished with that one. We can move on to number 2. Number 2 says a surveyor needs to determine the height of a large grain silo, so that's this right here. He positions his transit, that's the device here he's using to measure. It's 65 meters from the silo and records an angle of elevation. Remember, angle of elevation was looking upwards. So that's this angle right here looking upwards. And then it says if the height of the transit is 1.7 meters, so that's this height right here, 1.7 meters, that's how high it is off the ground. Determine the height of the silo to the nearest meter. Okay, so what I want to do, I already know that this height right here is 1.7. So if I move that all the way over to here, I know that this is 1.7. If I want to find the entire height, I am going to have to find this other missing height here first, and then add that with the 1.7 to give me the total height. Okay, so I'm going to call this x. I'm going to first find x, and then I'm going to add that with 1.7, and that'll give me my y. Okay, so let's find x here first. So we want to picture ourselves standing at this corner. If I go all the way to the other side, this is going to be the opposite. Okay, and then this side right here, it is nearby, so we'd call that adjacent. So I got O and I got A. Looking at our SOH CAH TOA, got to pick the one that has an O and an A, and that is the TOA. So I'm going to use the tangent ratio. So I got tan theta is O over A, and then I'm going to fill it in. So it was tan of theta, which was 52 degrees. Opposite we called x, and then the adjacent was 65. Okay, and then we'll put this over 1, and we can do our cross multiply divide. So x is equal to cross multiply 65 with the tan of 52. and then divide by the one across from the x, which is a 1. Okay, and then when I put that into my calculator, let's just do that. I'm going to do 65 times tan of 52. Okay, and then click, or actually close the bracket, and then click enter. Okay, and we got 83.1962. Next, I'm just going to bring my work up here. Just got to move my calculator out of the way. Okay, so we were wanting to find y, if you remember, that was the total height, and y is going to be equal to that 1.7 meters plus x. Remember, it was 1.7 plus x. So I now know what x is, so it's 1.7 meters plus that 83.19 number. Okay, and then we'll use our calculator, and I'll take that number I just had, and I can go plus 1.7, click equals, and I get 84.8962. Okay, so we got that, and then the question originally asked for this to be rounded to the nearest meter. Set it up right here, to the nearest meter. So that means we don't want any decimals. So going back down here, my y is going to be equal to, I don't want any decimals, that 8's going to round that up, so I get 85 meters. Make sure you guys only round your answer at the very, very end. That way it keeps its precision. Okay, so we're done that one. On to our last example, number 3 here. This one says the diagram shows two runners, A and B, so I can see those down here. These are runners. They're heading towards the finish line of a race, so they're heading towards this finish line. From an apartment window 80 meters above the ground and 20 meters behind the finish line. So that's going to be this person right here. They are back from the finish line and they are 80 meters up. It says that the observer measures an angle of depression of the runners to be 28 degrees and 24 degrees respectively. So that's how far they're looking down. Remember, angle of depression is looking down. It asks for us to calculate the distance between the two runners to the nearest meter. So we want to find this distance right here from A to B. Okay, so everything on the diagram is labeled for us except for these angles. So we need to put 28 degrees and 24 degrees onto our diagram. Now 28 degrees is the bigger one, so that is going to have to be this bigger angle. So that is 28 degrees, and then the 24 degrees is going to have to be the smaller angle. So this is 24 degrees. So something that you guys might know about these angles is that if this is 24 degrees, imagine if you were standing here and looking down at 24 degrees. Okay, if you had someone here and they wanted to look up to see you, they would also have to be looking up at 24 degrees in order to see you. Okay, so if this is 24 degrees, this angle here looking up is going to have to be 24 degrees. And that's only because these lines here are parallel. Okay, but just think about if you're standing here looking down 24, someone would have to look up 24 degrees to see you. So we can put 24 degrees into this angle here. And then I can use the same idea for this one. If I look down at 28, okay, I would have to look up at 28 for me to see the same spot. Okay, so this right here, this is 28 degrees. Okay, now we got our information onto our diagram. Now what we were wanting to find was we wanted to find this distance right here. Okay, but if I could find this whole distance and then take away this part, it would just leave me this distance. So I'm going to try to find this whole thing and then take away this piece. So we're going to give those names. We're going to find this one. We'll call that X. And then the one going the whole way, that one we can call Y. So the distance from A to B, that is just going to be taking Y and then removing X. So Y minus X. So I'll do that at the very end once I find X and Y. So let's find X here first. Okay, so using the angle here we had, we're going to be standing at this corner, so looking to the far end, that is the opposite, so I can label that. And then I wanted to find this side, that is nearby, so that is adjacent. So I'm going to use the O and the A, and that one is the TOA, or the tangent ratio. So I'm going to use tan. So tan theta equals opposite over adjacent. Then we can fill it in. So tan of the angle, 28 degrees. Opposite was 80, and then adjacent was x. Okay, and then put this over 1, and then cross multiply and divide. So cross multiply those two. 1 times 80, divide by tan of 28. Okay, and then putting that into my calculator, let's do that really quickly. So that's 1 times 80, which is just going to give us 80, and then divide by tan of 28 degrees. Okay, and that gives us about 150. So we'll write that down. Okay, so we got x. Then we're going to find y. I'm just going to move this out of the way. So to find this y here, we're going to use now this triangle. Okay, so I'm going to be looking from this angle. So we're standing here now. Okay, and this bottom side, or this y side here, that is nearby, so that is adjacent. Okay, and then all the way to the far end, that is opposite. So this is still opposite. So really it's the same as what we did in red. Okay, so opposite and adjacent tells us that we're going to use the tangent theta. So tan theta is O over A. Then we'll fill it in. Tan of 24 degrees equals, and then opposite was 80, and adjacent is y. Okay, and then put this over 1, cross multiply and divide. So 1 times 80. It's basically the same calculation as what we did in red already. It's just the angle is now different. Okay, so putting that into our calculator, let's pull that back out again. So I'm going to use the same calculation. I'm going to go up and grab it. I'll click enter. It'll move it down. Some of your guys' calculators might not be able to do that, but this one can. And then I'm just going to change the angle to 24 degrees and click enter. So I get that right there. Let's write that down. Okay, and then the very last thing we needed to do to find the distance from A to B, it was just going to be the whole distance across, but take away the x, take away this length. So y minus x. So let's just do that at the very bottom. So the distance from A to B is going to be y minus x, which that is equal to about 179.6829. Subtract 150.4581, and we'll use our calculator to do that. Okay, so I can take this number, I can go up, click enter on it, and then go subtract, and then I'll go up and get that other number, that 150. Okay, so I got all the decimals, so it's going to be really accurate. Click enter, and then I get this. So let's write that down. And then the very last thing we need to do, the question told us that we need to round it to the nearest meter. Okay, so that means no decimals. So we just want this as their last digit. So the 2 is not going to round up to 9, so we're just going to get 29 meters. So that was our last question. I'm just going to write our homework questions now here at the bottom.